Hi, welcome back. We're going to move into list comprehensions, a really interesting and fascinating topic. Now, list comprehension provides a really concise way to create a list. So let's look into that. There are three ways, essentially, to create a list of cubes. You can use the normal method, which is using for loop for n in range 0 to 10, not including 10 cubes. And then you append to the value cubes, which will actually create a list here, append n times n times n, okay, and print cubes, right? So let's just run that, and this is the value. Another method is actually to use the lambda function. Lambda, the argument x is equal to x times x times x. What is x? Is actually the range of 10. Basically, you are mapping the range of 10 to x and then convert it to a list. And when you run that, it's exactly the same. The method number 3 is list comprehension. So it's x times, basically this is x cubed, for x in the range 0 to 10. So this is actually list comprehension. You can see that this is actually quite attractive because it's short, it's sweet, and also it gets the job done as well. Alright, so that's what really quite exciting about this. If you're using for loop, looking at the combinations of Jimmy, Audrey, and Ono. So let's just say for student 1 in class 1, and then for student 2 in class 2. If student 1 is not equal to student 2, then combinations append student 1, student 2. Okay, so this is actually iterating through. You start with for class 1 is this one here. So you have for first one is Jimmy. Okay, so that's right now is Jimmy, student 1 is Jimmy. So for student 2 in class 1, if, and then you do, let's just say the class 1 first one is also Jimmy. If student 1 is not equal to student 2, not equal, then you append. If it's equal, then we go back, fetch Audrey. Okay, then you have Jimmy and Audrey, again, then Jimmy and Ono, and then you come back. All right, because we already finished through the end of the list. Come back, fetch the second one, which is Audrey, and on it go. Okay, so that's what you have, Jimmy, Audrey, Jimmy, Ono, and then on it goes. So if you take this same line of codes and you convert it to list comprehensions, this is what it looks like. A little bit messy, seems to be a little bit messy, but essentially it's the same core idea. This whole part here for student 1 in class 1, okay, is the same as for student 1 in class 1. And then you for student 2 in class 1, which again is the same one here. And then you have the if statement, okay. And then finally you have these combinations here. Notice that it is actually very concise. It's just one line versus the multiple lines here. To look at more example of list comprehension, you can have range -4 to 8 with a step of 2 and converting it to a list. So that's one way. If you want to double the number, excuse me, x to the power 2 for x in x underscore train. So basically you have square, 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 all of these. Applying absolute value, which is the same as this, and this is what you actually get here. Now, if you look at these list of dog names, if you want to actually remove, for example, some of the empty spaces, okay, that's what the strip does, is to actually remove the empty space. So what you have is that the space has been removed. What you have now is that American Bulldog without the space, Berger Picard, Bull Mastiff, Collie, and Harrier. And the other method here, notice that we do have some commas here that we do want to remove. You can loop through and make use of a method to remove the actual comma. Okay, so now that it's cleaned up, it has removed the comma, however, you still have the space. Okay, so because we are working on the Y train as well. So essentially, this is for Y in Y train, we're looping through these. For the value of Y, we're doing strip of the comma. This one is loop through the Y train. For the Y, we strip off any empty space. So now we want to do both. So this is what you do. Again, when you loop through, you do the strip and then you convert it into uppercase, and you also you removed the actual empty space, you also removed the comma. And that basically clean up everything for us. Okay, so we have a list in list. How do we unpack this list in list? You can actually make use of a for loop, such as this. Okay, that does it. The alternative is to use a for loop for num in list, and for n in num. Excuse me. How does this work? So first thing, you loop through the num in the list. Okay, so you're looping through all of these. Okay, what do we have? We have a list of 3, 0, 1, 2. Okay, and the other thing is that for num, for n is num, n in num, which is the 0, 1, 2, 0, 1, 2, 0, 1, 2. And for this n, we actually have it stand alone by itself. Okay, so essentially this works a little bit like this, but it actually unpack it in a slightly different manner. That's really list comprehension for you. And just want to cover nested list comprehension before we move on. So we stored it in the matrix. This is what the matrix looks like. This is actually very similar to the this list and list that we just did. We have the row for row in matrix. So we have 0, 1, 2 row here. And then for I in the range of 4, okay, which is 1, 2, 3, 4. So basically what you are doing here is that you are actually unpacking the whole thing. All right, so you actually tidy it in a manner that actually so that you go 1, 5, 9, and then 2, 6, 10, and then 3, 7, 11. Okay, so let's just stop this here for a second. I'm not too sure if you see the actual construct here. So this starts with for I in range 4. Remember, range is 0, 1, 2, 3, okay, because it's range 4. So we start with I is equal to 0. Now that I is 0, we feed I is equal to 0 in here. And we are running for row in matrix. Okay, so in the row in matrix is 0, 1, 2. Okay, so we are starting with row 0, which is that row there. We get a row there. And then row I is 0, because we're still here, 0. So we have 1, 5, 9. Follow? Okay, because we're iterating through the row. And then next time we iterate through the row again, I has been incremented to 1, which is 2, 6, 10. And then I becomes 2, 3, 7, 11. Okay, so that's really the basic idea here. Of course, this is quite a messy way of doing it. After a while, it gets a bit complex reading the list comprehension. And quite often, people use this zip function, which actually does a great job for this whole thing that we actually just did here, except that it's a tuple instead of a list. But nevertheless, it is actually fantastic for that. Recall that this asterisk here, this is from our previous lesson that we did cover this. We'll cover this in the form of keyword and also tuple. So let me refresh your memory here. Unpacking the argument list, which is this one here. Asterisk name which receives a tuple containing the positional arguments beyond the formal parameters. So asterisk, basically we are looking at the positional. The positional here is 0, 1, 2, 3. And then zip is combining 1, 5, 9, and then 2, 6, 10, so, and then converting it into list. That's the basic idea here. So if you want to know more about unpacking argument lists, you can look up these links that I've provided here. So when we come back, we will, let me just finish, let's finish off the delete statement so that we can actually look at tuples separately. There is a way to remove an item from a list given its index instead of its value, which is using the delete statement. So let's look at this. we have a cat list. We can delete cat's list 2, 0, 1, 2. Okay, and when you look at the cat list again, what you have is Javanese, Egyptian, oh, the Persian is gone. All right, so if you delete the cat list 2 onwards, okay, that basically means that the whole lot disappear. From 0, 1, 2 onwards, it's gone. So if you delete cat list, basically the whole cat list is deleted, is no longer defined. Okay, that means it's completely gone. Now this differs from the pop method, which returns a value. The delete statement can also be used to remove slices from a list. Okay, the delete basically deleted. Pop actually returns a value. So therein lies the difference between the two. With that, I'm going to stop right now. There's a lot of concepts we've gone through, and when we come back, we'll go through tuples and sequences.